Okay, hi guys. So in this lecture as well, we'll be continuing on seeing some more questions on the titration. So let's get started. So the first question in this lecture is, we have been given 1 gram of iron ore containing 50% Fe plus 2 and 50% Fe in plus 3 state. Fe plus 2 is nothing but ferrous ion and this is ferric ion, and the rest 50% is impurity. Okay, so this was dissolved in concentrated HCl solution. Okay, and then filtered solution was raised to 100 milliliter in a flash. Means no time gap was there when the filtered solution, as soon as the filtering of the solution was done, it was raised to 100 milliliter in quick succession. And then 50 ml of this solution was treated with 5 ml of M/10 K2Cr2O7. The question is, you have to find the percentage of Fa plus 3 in the original ore. Okay, so let's get started with the solution part. So only Fa plus 2 would actually react with K2Cr2O7, as K2Cr2O7 is a reducing, rather oxidizing agent. So it will only oxidize the substance or the ion which is present in less oxidation state. So Fe plus 2 is in less oxidation state. This can actually go to Fe plus 3 state, but Fe plus 3 is already in the highest possible oxidation state of iron, hence it will not go under any more oxidation. Hence K2Cr2O7 will only react with Fe plus 2. Okay, so we know that N factor for K2Cr2O7. So let's actually see this, that Fe plus 2 would be getting converted into Fe plus 3. So the N factor in case of Fe plus 2 would be 1, and K2Cr2O7 would be getting converted into Cr plus 3. So Cr is going from plus 6 state to plus 3 state, hence N factor of K2Cr2 would be 6. Okay, hence we can write that milli equivalents of Fe plus 2 for the titration would be equal to milli equivalents of K2Cr2O7, and we have been given that only 50 ml of from the 100 ml solution was actually reacted with 5 ml of M/10 K2Cr2O7. So milli equivalents of K2Cr2O7 would be number of rather the molarity of K2Cr2O7, which is 1/10, into volume of solution, which is 5, into N factor, which is 6. So this gives us milli equivalents of Fe plus 2 in 50 ml solution, as only half of the solution was used for titration. Okay, so what would be the milli equivalent of Fe plus 2 in 100 ml solution? So we can write that normality of the solution, milli equivalents of Fe plus 2 would be normality of the solution containing Fe plus 2 multiplied with volume of solution, which is 50, is 3. You can just calculate Okay, so the normality in this case would be 3 by 50. So if the normality is 3 by 50, what would be the milli equivalent of Fe plus 2? This is normality of Fe plus 2 in 50 ml solution. Normality of Fe plus 2 in 100 ml solution. Normality of Fe in 100 ml solution would be 3 by 50. Rather, the milli equivalents would be normality into volume of solution. Volume of solution will be 100. So the milli equivalents of Fe in 100 ml would be 6. Okay. So now, as you know that milli equivalent can also be written as weight of the solute, which is Fe plus 2 in this case, divided by equivalent weight of Fe plus 2. Equivalent weight of Fe plus 2 would be 56, and the n factor of Fe plus 2 in the reaction was 1. Okay, so this is still by 56, which should be equal to 6. Obviously this is milli equivalent, so you have to multiply it with 1000. This is equivalent. For milli equivalent you have to multiply it with 1000. So this gives us weight of Fe plus 2 would be nothing but 6 into 56 divided by 1000 grams. Okay, so this gives us weight of Fe plus 2 would as 0.336 grams, and we know that the original sample contains only 0.5 grams of Fe plus 2 ferrous ion and ferric ion, in which 0.336 gram is ferrous ion, hence ferric ion would be 0.5 minus 0.336. This gives us ferric ion as 0.164 grams. Okay, so percentage of Fe in Fe plus 3 or ferric ion in the original ore would be nothing but 0.164 divided by weight of the ore, which is 1 gram, multiplied by 100. So this is 16.4%. Okay, now let's see one more example before going on to the next concept. So this question is, we have 30 ml of a solution of KiO3 which reacted with exactly 25 ml of 0.1 m Ki in acidic medium. According to the reaction, IO3 minus plus 5 moles of I minus plus 6H plus gives 3I2 plus 3 moles of H2O. You have to calculate the molarity of KiO3 solution, and then 50 ml, let's say 50 ml of this KiO3 solution is treated with excess of Ki in acidic solution, and the liberated I2 was treated with 0.15 N of Na2S2O3. Okay, so you have to calculate what volume of Na2S2O3 is required for the same. So first part is calculate molarity and second part is calculate volume of Na2S2O3 required. So this question is for your homework. So I hope you all do this question, and we'll be discussing the solution in the next lecture. So till then, good luck and goodbye.